Hello all, welcome to the playlist of network analysis. In this session, I am going to discuss important questions with relevant equations, which will be helpful for solving the problem in the network analysis. So I am going to make a problem section separately. However, if you want to solve the problem, you must see this video so that you will be getting a good information about how to solve the problems. Also, few questions will be appearing in the form of theory type. So we'll discuss in detail. So let's move on to the session. So here you need to study about the difference between ideal and practical voltage source, also the ideal and practical current source. Study with the equivalent circuit, then dependent and independent sources. These are the things you need to focus. And the question may come like compare ideal and a practical voltage source, compare ideal and practical current source. What are the differences between independent and dependent sources? What are the notations? So explain with the diagram of voltage control voltage source, current control current source. So you have to explain with the notation and voltage gain equation. So state and explain KVL and KCL that we cannot say it will ask because it is a part of basic electrical engineering. Then advantages and applications of dependent and independent sources. These are the questions which you can expect for the university examination. So what is source transformation? So how do you convert a voltage source series with the resistance into current source parallel with the resistance? Explain star delta transformation. So you can expect the derivation. How do you convert the star into delta and delta into star? Write the conditions under star and delta transformation. Define the mesh and node analysis. What are the rules? You have to study the rules to solve the problems. Then differentiate mesh analysis and node analysis with the equations and the sufficient steps. Write the general form of mesh and node equations. So for AC network analysis, explain how impedance is used in place of resistance. Because if you are analyzing for AC network, we should have impedance in spite of resistance. So entire equations is summarized in this table. You can have a look on this. Practical sources. So the general equation, the load voltage equal to terminal voltage minus load current into source resistance. Source transformation, convert the voltage source to current source and vice versa. So you can use the formula V is equal to IR, correct? Suppose if you want to convert current source into voltage source, you must calculate the value of voltage source and vice versa. Suppose if I want to calculate the current source, I need to take the ratio of V and R. Star and delta transformation. This formula you have to remember. I will show you entire formula in my notes. Let me summarize the entire content. Later I will show you the notes. Then mesh analysis. So in the mesh analysis, you have to can identify the unknown current. In the node analysis, you can calculate the unknown voltage. Correct. So yeah, for the node analysis, you can use the formula V node minus V adjacent node divided by R. That means current. Sum of current meeting at a junction that is equal to 0. So these formulas should be known for you to solve the numerical example. Apart from that, you should understand about like dependent and independent sources, and you should know the concept of super node and super mesh. Okay, so if you go for like a super mesh, you can simplify the equations. If I go for node equation, no super node concept, again you can simplify the node equations. So the most numerical questions, star delta transformation, then a source transformation, and the source shifting, and the node analysis and mesh analysis. You can expect so many questions. And the super mesh and super node concept. These are the most probable questions you can focus on the numerical example. I'll make a separate session for numerical example. One or two sections separately for numerical example. Numerical questions I'll make separately. So today I'll be showing you the important equations with the help of my notes. You can see this basic equations. V is equal to IR. KVL means summation of voltage plus total drop in the mesh that is equal to 0. KCL is nothing but the sum in the KCL we are going to apply the summation of current meeting at a junction that is equal to 0. So terminal voltage equation and terminal current equation. Here you can terminal current equation, it will be like a current division rule. Then for star like a conversion of like a star into delta. So you can use this equation. Okay. So similarly, conversion of delta into star, you can use this equation. Similarly, impedance and admittance equation. So these are the valuable equations which will be helpful for solving the numerical example. So prepare a short notes and make a important notes on all the equation. Let me show you my handwritten notes so that you will be getting a better idea. Okay. So let me direct you my handwritten notes. So now you can see my notes. Here you should understand what is practical sources. So like in the case of practical sources, we will be having a voltage source with impedance like this. a voltage source, and RS, which is connected series. Ideal source means there is no internal resistance. That's a major difference. You can see the graph also. Okay, check out the graph. Then you may ask a question like what are the difference between ideal voltage source and practical voltage source. So you can compute the voltage across the load by using KVL. This is basically KVL. Okay, applying the KVL, I can able to calculate the unknown voltage. One example is given for you. So how to calculate the VL, okay, and how to calculate the IL also. So IL, you can apply Ohm's law, VS by RL plus R internal resistance. Then ideal current source. So what is the meaning of ideal current source? Here, ideal current source is nothing but the current source in this particular fashion. Okay, there is no parallel resistance. But if I talk about parallel resistance, there will be always an RP which is connected parallel to the ideal current source. So using current division rule, you can calculate the load current. So IS into current through the opposite branches divided by total branch resistance, current division formula. Then independent sources. There are two types, independent voltage source and independent current source. This is the way how to represent the independent voltage source. Then independent current source is nothing but a current source which will not be depending on the output, right? Never depend on any other factors on the output. So dependent source means you will be we are having four types: voltage control voltage source, voltage control current source, current control voltage source, current control current source. So using the diamond, it's a diamond symbol, you can represent the voltage control voltage source. Okay, so study the general formula, and V out is equal to A into VAN. So you can study the key features like high input impedance, low output impedance, adjustable gain. So A is known as gain, A can be adjusted. So applications, amplifier, signal processing, then advantages, minimum loading effect, flexible gain control. Drawback is noise and bandwidth limitations. Similarly, voltage control current source. This is known as voltage control current source. So I out can be determined by A into VAN. A is known as gain, okay, transconductance gain. Okay, so unit is Siemens. So examples and applications, FET, op-amp circuit, all are comes under the voltage control current source. Do remember this, how to draw the voltage control current source. Current control voltage source. This is the way how to represent the current control voltage source. Do remember this, input current and output voltage. So output voltage you can determine by using the simple equation. Output voltage is equal to A into I. In terms of current, you can write output voltage. Current control current source. So this is the way how to represent the current control current source. So output is current only. So input is current, output is also current. I output is equal to beta into IN, where beta is known as current gain. Best example is BJT. So try to remember those equations. Then star delta transformation. It is very helpful for solving the network to reduce the complex network. So you can convert star into delta and delta into star by using the formula. Okay, please do remember the formulas. Okay. So this is my star connection. I want to convert into delta. So R1 RA I can compute that R1 R2 by R1 plus R2 plus R3. Okay. Similarly, RB RC I can calculate. Use this formula. Similarly, R1. Okay, delta to star. First formula is star to delta, then delta to star you can remember. Okay, so advantages. Network will be simplification will be very easy. Then drawback, like not possible to operate star delta connection parallel with the star or delta delta connection. That is a major setback. So remember the formula, that is most important. Okay, so how to convert star to delta? Any notation you can use it. We have a star, then you can see the delta. So how we can write delta RAB, RARB, RARB, then RBRC, RCRA divided by RC. Here A and B means C is not available, so C comes to denominator. RBC, this is RBC. Okay, RBC. So RARB, RBRC, RCRA. Numerator remains same only, but the denominator, the unknown element. BC means unknown element is RA. CA means unknown element is RB. Like this, you can make a short, remembering tip, memory tip. Delta to star. So delta to star, how to convert delta to star? For example, RA. RA means how to write RA. RAB into RCA divided by RAB plus RBC plus RCA. Here, see here, denominator remains same. Only numerical is going to change. Correct? So that point you have to remember. However, you have to remember this and study the concept how to convert star into delta and delta into star. So mesh analysis, there are protocol to find out the unknown current. So we'll be considering the closed path or a mesh. So we are applying the KVL. So we'll be able to calculate the unknown current. Node analysis, we are going to apply the KCL. Using the formula, you can calculate the unknown current. V node minus V other node divided by R. Source transformation, voltage source series with the resistance is equal to current source parallel with the resistance. and current source parallel with the resistance equal to voltage source series with the resistance. This conversion is very important. Okay, so there are some numerical example. I'll make a separate session for this. Okay, however, you can have a look on this. This kind of problem will be definitely asked in the university examination. So we'll be applying like a source transformation and a source shifting accordingly. Okay, so wherever you are seeing the current source into current source parallel with the voltage source, you are going to convert voltage source series with the resistance. Okay, so current source parallel with the resistance equal to voltage source series with the resistance, and vice versa. Voltage source series with the resistance equal to current source parallel with the resistance. And finally, you should know about how to calculate the series parallel R1 R2 by R1 plus R2 if two resistors are connected in parallel. If there are two resistors are connected in series, you should know about R1 plus R2. Okay, so those concepts you should know. Then I think it will be very easy. And you should take care about polarity. If the difference in polarity means you have to take the difference. Okay, so those things you have to remember. Similarly, like the voltage, calculation of unknown voltage. Okay, using these kind of problems also you can expect for the university examination. Okay, unknown calculation of unknown voltage, unknown current, all those things. Okay, so source transformation and source shifting also very important. So we can go through this. Now, so you can study these problems. So I'll make a separate session for like these problems on KVL, KCL, etc. And also you should able to solve the problems like star delta transformation. Okay. You should have a better idea about how to convert star into delta and delta into star accordingly. And should able to know what is series and parallel. Fine. So this is another type of problem like a source transformation. You should able to know how to convert, see, 1 ohm and 1 ampere. How will you convert 1 ohm into 1 ampere? Like we can convert in the form of like see note, you may ignore 1 ohm and 4 ohm resistor here, only like this current you are able to consider only current source here, 15 volt and 3 ohm. So how we can convert into current source? 15 upon 3 means 5, right? 5 ampere, it is 5 ampere is written over there, then 3 ampere as it is. So 1 ohm and 4 ohm can be ignored accordingly. Ultimately you will be able to get the current source like this. Ultimately you are able to get like 1 ampere parallel to the 1.2 ohm. So if you want, you can convert 1 ampere parallel to 1.0 ohm is equal to like 1.2 ohm series with the 1.2 volt. So that is actually current source, current to voltage source transformation, right? So like this, you can plan for various questions. That will be really helpful for you. So these kind of problems also several times it is getting repeated. Okay. So for the problem solving session, I can summarize the entire thing in a clear and easy way. Fine. Next is actually mesh analysis. You should know like different type of meshes, how to solve the mesh equations. So some, in case calci is not allowed, you can go for Cramer's rule. You should know about the Cramer's rule. Fine. Okay. So these kind of problems also you can expect. Have a look on this. So all the type of problems I have solved. So let me share you at the like in my videos in my problem numerical session. I'll make a separate session. Don't worry. So these kind of problems in AC circuit also you should able to solve the problems. In that you should know about the complex numbers. Then only you can solve the reactance. So here whenever it comes to AC, we should consider impedance and resistance and reactance. That means Z is equal to R plus JX. So complex number comes into picture. At that time we should know about like a complex number. For the addition and subtraction, you should make it into rectangular form only. For multiplication and division, you should convert into polar form. That point you have to remember. Then you should able to know about the Cramer's rule. Also the concept of like a super mesh. Super mesh concept you should know. So we are applying the super mesh concept. Correct. If you see these kind of problems, you apply the concept of super mesh. So it will be easy to solve. Right. So you have a look on the concept of super mesh. Then it will be easy for you. Fine. Like there are problems, so we can make use of like a super mesh and like source shifting, source transformation. So if you solve these kind of problem, that will be easy for you. Okay. Yeah. So previous year question papers all numerical example, I'm going to make a separate video. So I hope you got an idea how to prepare and what kind of problems will be asked in the university examination. So for the time being, you should focus on the concept first. Later, in the coming session, please watch completely. So complete numerical will be shown in the next session with a brief explanation. So if you practice it, and notes also will be shared. These two PDF I am going to share in my video description. Kindly download and you can start preparing network analysis. Okay. And numerical, I'll make a separate session. Individually, I'm going to explain the numerical content. Happy learning. I wish you all the very best. Feel free to contact me in case any difficulties. Thank you all.